Hi guys, as you might have already noticed, I'm not at school today, I'm at a conference, and so I did a video lesson for the substitute to play, and if all goes as planned, it should be about 25 minutes, so we'll see how it goes. The first thing that I'd like you guys to do is take a look at your guided notes, and in part 1, part A, you're going to see it says the following diamonds have a pattern. You can use the two side numbers from the diamonds to get the top and bottom numbers. Work with your group to try to identify the pattern. I'd like you to take a look at these 4 little diamond puzzles and see if you can figure out what the pattern is. And while you're trying to figure that out, the substitute teacher is going to pause the video, and when everybody's ready, we'll start up again. So if you'd like to pause it now. Alright, so what you guys probably noticed is the pattern is if you take the two side numbers, if you multiply them together, you get the top number, and if you add them together, you get the bottom number. And so now that you think that you have the pattern, why don't you guys try filling in the puzzles that are half blank. And once again, we'll pause the video, and when you're ready, we'll start it back up again. Alright, welcome back. So what you guys did is you multiplied to get the top number, 14, and you added to get the bottom number, which is 9. And you did that for all of those. 4 times 1 is equal to 4. 4 plus 1 is equal to 5. And same thing throughout. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. Negative 9 times negative 4 is positive 36. A negative times a negative is a positive. And negative 9 plus negative 4 is negative 13. Okay, so those puzzles are not going to be enormously useful for tonight's homework, but later on this week. These are really going to help us make some difficult problems a lot easier. This might ring a bell, by the way, with something you did freshman year. It depends on what teacher you had freshman year, because different teachers do this stuff in different ways. But the main thing we're doing today is classifying polynomials. We're going to be naming polynomials, and we're going to be adding and multiplying polynomials. And basically, all a polynomial is an expression involving coefficients and exponents. Or sorry, and variables. I apologize for that. There we go. So a polynomial is an expression involving coefficients and variables. Here's some examples. 3x squared plus 5x plus 1. That's a polynomial because it's got some coefficients, 3, 5, and 1. It has some variables, x squared and x. 5xy minus 4. That's also a polynomial. It has two variables. It has x and y. We could have 7x to the 7th. That's a polynomial, even though it only has one term. X is a polynomial. Even just the number 9 is a polynomial. It doesn't have to have variables. So it could just have variables. It could just have coefficients. It could have a combination of both. It could have more than one different kind of variable. It's a pretty general term. The degree of a polynomial in one variable is the highest exponent. The highest exponent in the polynomial. Here's a couple examples. If we have 5x to the 15th minus 19x squared plus 4, the degree is equal to 15. You look for the highest exponent in the entire problem, and that's your degree. We could try another one. 19x to the 3rd minus 5x plus 1. The degree is equal to 3. Say you have 9x minus 7. Well, you're looking for the highest exponent on a variable in the problem. So in this case, the degree is actually equal to 1, and it might be surprising. The reason the degree is equal to 1 is you could pretend that 9x minus 7, the x has a invisible first power on it. The last one I'll put up here is just the number 5. The number 5 actually has a degree of 0. The degree is equal to 0. And the reason that is, you could think of 5 as 5 times x to the 0th power, because x to the 0 is just 1. So yeah, that's the definition of the term degree. And then finally, there's another vocab word I want to show you. The term of a polynomial is any part of the polynomial that is joined to the expression using addition or subtraction. So I guess I can give you some examples of that. Say 3x squared minus 5x plus 9. This has three terms. So this is three terms. And I can highlight them. First term, second term, third term. 3x squared is a term, negative 5x is a term, and positive 9 is a term. We would say that 3x squared is the first term, negative 5x is the second term, and 9 is the third term. Anything that's joined to the polynomial using addition or subtraction is one of the terms of the polynomial. I guess we could, try something else, maybe 9x to the 11th. This only has one term, and that one term is 9x to the 11th. There's no other terms that are joined to the polynomial using addition or subtraction. Okay, and now let's try classifying polynomials by their number of terms. So basically this is just a set of vocabulary terms that we can name polynomials based on how many terms they have. So we have monomials, binomials, trinomials, and polynomials. A monomial only has one term. A binomial is going to have, as you might guess from like bicycle, two terms. A trinomial, as you could probably guess, like a tricycle, 3 wheels, so a trinomial, 3 terms. And a polynomial is 4 or more. Let's do some examples. So a monomial only has one term. And an example of a monomial would be maybe 5x to the 7th power. It only has one term. Just the letter x, just the variable x, that's a monomial. Maybe negative 9, that's also a monomial, if it only has a single term. A binomial, 2 terms. So x minus 5, that's a binomial. X to the 5th minus 4, that's a binomial. X plus y, that's also a binomial, 2 terms. A trinomial, 3 terms. And I'll just do one of them in here. Maybe 9x to the 5th minus 6x squared minus 5. That's a trinomial. And then a polynomial that can have 4 terms, 5 terms, 6 terms. It's just a general term for any polynomial that has more than 3 terms. So 4 or more terms. There actually are names for polynomials that have more than 3 terms. We just use polynomial just as a blanket term to make it simpler. So say 3x to the 4th plus 2x cubed minus 5x plus 3. That's a polynomial. It's a polynomial with 1, 2, 3, 4 terms. And by the way, if at any point I'm going too fast, the beautiful thing about a video is you can just raise your hand and ask the teacher to pause or rewind. So if it does seem like I'm going too fast at any point, or you don't have time to write something down, just ask and she can move back. So next is classifying polynomials by degree. So by degree, we have constant terms, linear terms, quadratic polynomials, and then finally cubics. There are things that are higher than cubics, but a constant term has a degree of 0, linear is degree of 1, quadratic is degree 2, and a cubic is degree 3. Now this sometimes confuses people because sometimes when you think quad you think 4. There is a reason that quad for 4 matches up with a degree 2 polynomial. I'll tell you guys about that when we get back. But cubic, that should be pretty easy to remember because a cube, that's in 3 dimensions. So, or cubing something, x to the 3rd. So, okay, so for a constant is just a number with degree 0. So it's just a number. And that would be, an example would be 5, 11, 13. You get the idea. And the reason that it's has the degree of 0, you could think about, say, 11 being 11 times x to the 0. Its degree is 0. A linear term, its degree 1. So it doesn't matter how many terms it has for it to be linear. So you could say 5x is linear. 19x minus 4 is also linear. Even though it has 2 terms, the only important part here for it to be called a linear polynomial is that it has a degree of 1, so that the highest exponent is 1. Likewise for a quadratic, so it's degree 2. So x squared plus 5x minus 1, that's a quadratic, and the reason it's called a quadratic is because its degree is equal to 2. It doesn't really matter how many terms it has. This particular polynomial that I just wrote down, x squared plus 5x minus 1, has 1, 2, 3 terms, but that's irrelevant in this case. It's a quadratic because we're naming right now by degree. So this is a quadratic trinomial. The degree is 2 and the number of terms is 3. Another one I could give you, say, would be 5x squared minus 9. That's a quadratic as well. The reason is the degree is 2. This would be a quadratic binomial. And then a cubic, its degree is 3. So say x cubed plus 5x minus 9, that's a cubic trinomial. The thing that makes it cubic is that degree of 3. You could even just have, I don't know, 19x cubed. This would be a cubic monomial. Its degree is 3, which makes it a cubic. And then if you were trying to classify it by the number of terms, you would say that it's a monomial because it only has a single term. So when you're naming by degree, just look at that largest exponent. That tells you what its name is by degree. And, here's a couple that we could try classifying. So this first polynomial, x plus 4, there's an invisible little 1 on that x. So its degree is 1. So if we're naming this by degree, if the degree is 1, it's linear. And by the number of terms, well, there's 1, 2 terms. So if there's 1, 2 terms, it's a binomial. Sorry, so number of terms is 2, and then the name is binomial. So this first one we're working with is a linear binomial. This next one, well, first naming by degree. The degree is 3, which is a cubic. The number of terms, well, 1, 2, 3 terms. So if it has 3 terms, it's a trinomial. So this is a cubic trinomial. And then this last one, actually, in order to really figure anything out about it, first you have to simplify. So I'm going to distribute this negative and write this as 2x squared minus 3x plus 5. Before naming, you've got to simplify. So you might want to write that down in your notes. Before naming, simplify, and combine like terms. And now we can do that. We've distributed that negative. There's no like terms to combine. So the degree looks like it's 2, which would be a quadratic. And then the number of terms, let's see, 1, 2, 3 terms. If it has 1, 2, 3 terms, then it's going to be a trinomial. So we have a quadratic trinomial. Okay, if you need time to take this down, just ask for the video to be paused, but I'm going to keep moving since you can rewind or pause me whenever you need to. Okay, this next thing might seem a little new to you. This may or may not be something that you did in your last class, multiplying polynomials using the area model. Essentially, we're going to use our knowledge about finding the area of rectangles to be able to multiply together x plus 7 and 2x minus 5. We're not using FOIL right now, if you remember FOIL, but so let's see, x plus 7 times 2x minus 5. What I'm going to do first is x and 2x. If I multiply that together, that's 2x squared, because the 1 and the 1 get added together to make it a square. And then 2x times 7 is 14x. Negative 5 times x is negative 5x. And finally, negative 5 times 7 is negative 35. So the last thing I need to do is combine my like terms. If you look down the diagonal, there's often like terms. So I'm going to have 2x squared. I got that from right here, the 2x squared. Then I'm going to combine like terms down the diagonal. And let's see, if I have 14 x's and I take away 5 x's, I am left with 9 x's, so plus 9x. And then finally, I'm going to do minus 35. Just right there. And this is my final answer. This guy right here. That's my final answer. I multiplied together x plus 7 and 2x minus 5. We could try the next one, but in order to make this work, in order to use this kind of box or this area model to make it work, I need to distribute the 2. And this 2 only gets distributed to one of the sets of parentheses, not both. So this is going to be 4x plus 2 times 3x minus 2. Notice that we only distributed to the first set of parentheses. Okay, so when we write it down, 4x and plus 2, 3x and minus 2. Let's multiply it all out. So 3x times 4x is 12x squared. Notice that this first term, I'm adding the x to the first and this x to the first to get an x squared. 3x times 2 is 6x. Negative 2 times 4x is negative 8x. And finally, negative 2 times positive 2 is negative 4. And to write my final answer, my first term is going to be 12x squared. So I'll go ahead and write that down, 12x squared. Then after that, if I combine like terms, negative 8x and 6x are going to make negative 2x. And then finally at the end, negative 4. So that's my final answer. My polynomial is 12x squared minus 2x minus 4. It looks like a quadratic trinomial, degree of 2 and 3 terms in it. Okay, why don't you guys try example 3 on your own? I think that's worthwhile trying on your own right now. So you can pause the video, give it a try, and when you guys are ready, the teacher can start the video back up. And in fact, it's probably worthwhile that you also try example number 4 if the video is not already paused. And if it was already paused, you could just pause again and try this one. So here they both are. Try example 3 on your own, try example 4 on your own. Notice what we did for example 4. X plus 3 times x plus 3 is x plus 3 squared. So go ahead and try it. Okay, you guys are probably back now. So x times x, x squared. X times 4, 4x. Negative 4 times x, negative 4x. And negative 4 times 4, negative 16. If you combine like terms, notice down the diagonal they cancel. So that's kind of a cool thing. So we only have x squared minus 16 left. Even though we multiplied all this stuff out and combined like terms and we were expecting maybe like 3 terms, we only had 2. And that's because we canceled down the diagonal this time. This is called a difference of 2 squares. This is called a difference of 2 squares. And the reason is we have x squared, which is a perfect square, negative 16, and 16 is a perfect square. So let's try this next one. X squared plus 3x plus 3x plus 9. Notice what I did. X times x is x squared. X times 3 is 3x for both of them. And then 3 times 3 is 9. Okay. So this first one is called a difference of 2 squares. And basically, a difference of 2 squares, if you have a plus b times a minus b, that multiplies out to make a squared minus b squared. This next one is called a perfect square trinomial. And the reason for that, we had like a plus b quantity squared. We had the same thing multiplied together. The first term is a squared, and then it's plus 2ab plus b squared. This is just the general pattern for any time you have a problem that looks like this. You guys don't have to have these formulas memorized now, but just kind of keep them in the back of your head and notice that there are patterns to some of these multiplications, and those patterns will come in handy later on in the chapter when we're doing tougher stuff. So write the formulas down for now, and you don't have to study them quite yet, but in a couple days they're going to become very useful for us. And by the way, this box method works even if you have, say a binomial times a trinomial. We could still make it work. So let's say x squared plus 3x minus 1 and x plus 2. You can expand these rectangles out, these boxes out, to fit as large or small of polynomials as you have. So x times x squared is x cubed. X times 3x is 3x squared. X times negative 1 is negative x. And continuing on, 2 times x squared is 2x squared. 2 times 3x is 6x. And 2 times negative 1 is negative 2. So notice what we've ended up with. We still have like terms down the diagonal here. So let's combine our like terms and we'll write our final answer. So this first guy, we're going to have, looks like x cubed. And then 2x squared plus 3x squared down this diagonal is 5x squared. You're adding these like terms. If you have 2x squareds and then you get 3 more x squareds, total you have 5x squareds. And then continuing down the next diagonal, 6x minus x. Well, if you have 6 x's and you take away an x, you've got 5 x's. And then finally, minus 2. So there's our answer. X cubed plus 5x squared plus 5x minus 2. That's why I really like this method. These boxes can be expanded to do as big or small of problems as you could be faced with. So that's kind of neat. But if you don't like these boxes, it might be because your teacher showed you something different when you were in Algebra 1, and that was probably called FOIL. You are certainly allowed to use FOIL to check your work, and even you can use FOIL for a lot of the homework problems. I do want you to practice with boxes on at least half of the homework problems tonight. So you could either do all boxes or you could do half boxes and half FOIL, whatever you choose on the homework. But FOIL was like first, outside, inside, and last. If you learned this before. It's another way of multiplying out polynomials. And really, you get to choose what works better for you. But when we multiply the first terms together, x times 2x is 2x squared. Then the outside terms, x times negative 3 is negative 3x. Then the inside terms, 1 times 2x is 2x. And then the last terms, 1 times negative 3 is negative 3. Combine like terms, 2x squared minus x minus 3. So FOIL is a perfectly good way to do a problem like this. You could have also made a box and you'd get the same answer. I'm not going to, write everything in there because we've already done a few of these. But x plus 1 and 2x minus 3, if you use a box, you'll still get that same answer of 2x squared minus x minus 3. And then finally, writing quadratics in standard form. This is just a really quick final part of the notes. A quadratic equation is an equation of the form y equals ax squared plus bx plus c. All I mean by that is, something like y equals 5x squared plus 7x minus 4, or y equals x squared minus 5, or y equals 5x squared plus 9x. A quadratic equation really is just the same quadratics we were looking at earlier on in the notes, so degree of 2. And the reason it's called a quadratic equation now is because we have a y equals in it. So that's the only thing that differentiates a quadratic equation from a quadratic polynomial, which is what we were working with earlier on in the notes. Basically, to put a quadratic equation into standard form, multiply, then combine like terms. So on your homework tonight, you're going to see stuff that's like, I don't know, say y equals 5x minus 4 times x plus 1. Your goal for the homework assignment to put this into standard form, and by standard form I mean ax squared plus bx plus c form. All you have to do is multiply out. So make a box, put 5x minus 4 and x plus 1 as the sides of your boxes, or sides of your box, I'm sorry, and then multiply into it. So 5x squared minus 4x plus 5x minus 4, combine like terms down the diagonal. And your answer is going to be y equals, let's see what we get. Looks like 5x squared. So 5x squared. And then down the diagonal, 5x minus 4x leaves you just with an x, so plus x. And then finally, minus 4. So y equals 5x squared plus x minus 4. That's our final answer. This is our standard form equation for this quadratic that we started with here. All right, guys. So thank you for your patience. I hope this lesson made sense for you. I hope we'll start up again tomorrow. I'll get those tests back for you. And the last thing is there's some group practice problems here, but I think probably it's best that we start our homework, and we can do this problem again tomorrow as an opener. So have a great day. Study hard on that homework, and I will see you guys tomorrow. Thanks very much.